2. I just did these last couple days a little different. I think it's helpful to see it this way. Okay, so bring all that attention. Bring all that attention up here. All we're doing is converting between our forms. Remember the first day when I broke this down, I had the 3 forms up here. Okay. Now, standard form we know has the A, B, C. We were dealing with those kind of when we were going over some problems, reviewing homework. We learned yesterday that standard form, we can use that and complete the square. And when we complete the square, we end up in vertex form. Okay? Now, vertex form is helpful because from vertex form, you can very easily find the vertex. It's just going to be whatever your H and your K values are. So it could be that if you have it in this form, standard form, you need to know the vertex. You might just, hey, complete the square, get it down here. You could find your vertex from the numbers that are there. You could also, from standard form, complete the square to find the axis of symmetry. That's just going to be x is equal to whatever H is right here. Okay, so that's one pathway we already did. Now, we know one of these pathways here. If I have standard form, which is easy to find what? Y-intercept. It's just whatever my C value is. And I know if it's happy or sad, that's easy because we can look at the A value right off the bat. Now down here, we're going to use a method today. Has anybody heard of the X method? Yeah, a little bit. That's about as much as the other Math 2 Plus class. So I know it's new for a lot of folks. It's kind of like a pattern. You try to find numbers that match in a certain way. When we get to factored form, then we could find the x-intercepts. And when I have x-intercepts, I'm talking about where it crosses the x-axis. So it could be, we're shopping around for all the things we need in order to graph. We have the graph here in standard form. We need to know the x-intercepts. You got to get it into factored form. So follow the arrow. Use the x method to get into factored form. You could then find it there. You can go back and say, well, I need the vertex and axis of symmetry. You can find that from the standard form. We learned that. Or you can complete the square. And then whatever number's in there, that's going to be our axis of symmetry. Now, those are our processes. Now we just have to figure out, we know FOIL. We know completing the square. FOIL's to go the other direction to get back here. But we have to learn the X method now. Okay? X method's like a game. Now, that's a lot of detail on where you go, what you find, all this. Okay? The classwork for this is very explicit as some hints to kind of get you started. Okay? But you're going to be told exactly what you got to convert. So we're going to do these problems next. We're going to have to go from standard to factored, standard to vertex, and so on. Okay. If you are here in factored form and you got to get to vertex form, you got to FOIL it out to get to standard, and then you got to complete the square to get to vertex. I know these are a lot of work, so you won't have too many of these to do when we get to our assessment. So don't even worry about that part. But we want to know how to do the X method, going from standard to factored form. The first step is draw a big X. That's an easy step. Check. Got it. You take your B value. So we're going from standard form. So in standard form, our B value is right in front of the X. You put it on top. So I put the 5 on top. You take your C value. That's the constant. Put it on bottom. 6. The name of this game is find two numbers. Find two numbers that combine and multiply to give us 6. Combine and add to give us 5. So you say, well, those are two things. Those could be different numbers. How do I figure out which one's which? There's a limited number of combinations that multiply to give us 6. You could say, well, if you add to give you 5, it could be, 4 plus 1, 3 plus 2, 1 plus 2, or 1 plus 4. It could be all these things. But we're going to start. We're going to start by figuring out these numbers for 6. 6 is what? What multiplies to give us 6? 3 and 2, negative 3, negative 2. 6 and 1. 6, 1, negative 6, negative 1. Those are all the options. So I want you to have that on the side right here on your notes. Go to make that table. And then circle, those are the multiples of 6. Circle the two numbers that add to give you 5. 6 and 1, add to give you 7, negative 6, negative 1, negative 7. Negative 3, negative 2 is negative 5. 3 plus 2? 5. Let's see if it works. 3 and 2. Do these multiply to give us 6?
Yeah.
Add to give us 5? Yes. So what we have is essentially this trinomial has been converted into two binomials. What do you think is going to go there? X what? X. This is a positive 3 plus 3. This is a positive 2 plus 2. Done. Yes. Yes. It won't matter the order, though. Yeah. Just because what you said, 2 times 3 is 6, 3 times 2 is 6. Doesn't matter which comes first. You're just multiplying it all together. Let's try another one like this. So how about this one? Y is equal to, let's go, x squared plus, let's make it a little trickier. Minus 3x is equal to, no, plus 2. It's just plus 2. Set up your box. Set up your x. What goes in the top? You might have to look. You might put up there B, C. They're going to add to give us the top, multiply to give us the bottom. So what goes on the top? Negative 3. What goes on the bottom? 2. Now, what values multiply to give us 2? You're like, well, how do we add to get a negative, multiply to get a positive? Let's see. 2 times 1, negative 2, negative 1. That's all of them. It's fine. Which one works for us? So let's see. Negative 2 and negative 1. Do those multiply to give us positive 2? Do those add to give us negative 3? We found it. So we know that it's y is equal to x minus 2, x minus 1. And if you FOILed that out, you go right back to where we started. Yeah. Want to see another? Would it be helpful to see another? Want is not always the right word. Let's see. Y is equal to, let's go one that's straightforward. Let's go plus 6x plus 9. Draw your x. Those will be on top. Just teaching right now. Just teaching with the lesson.
Sorry.
That's wrong. That can't happen again. You can walk around next time, please. All right. So let's make our x. What goes on the top? 6. What goes on the bottom? Good. We're adding to get you 6. Multiply to give us 9. So let's look. What gives us 9? Multiplying to give us 9. 3, 3. Negative 3, negative 3. 9, 1. Negative 9, negative 1. Which one of those adds to give us 6? 3. Y is equal to x plus 3, x plus 3. Aaron.
Is this method always going to work?
Yes.
Because it seems like it would be hard to find the divisibles, whatever.
Okay. You're right. There are going to be situations, where it is not factorable. Okay. When it's not, when you think it might not be factorable, that's where we have our fail-safe is our quadratic formula, which we're not going to learn yet. So all the examples for the homework and classwork and moving forward till we get to this are going to be factorable at this point. Because I want you to practice it and get confident that that's going to work out every time. Okay. Say what?
That works for when it's a homework.
Okay, so yeah, you can always use the homework examples. I want to do these 3 conversions. You'll see how it's going to work. I'm not even going to talk about what parts we can, what we can find from it yet. But let's see if we can figure this one out. Okay. Standard form to Standard form to factor form. So let's look at our map. Standard form, factor form, X method. Go and do the X method for this one up here. You start with NX.
Oh no,
Is that a homework problem?
yeah, it's the same number. It's just different.
Oh, from last night? They use consistent, like similar trinomials, because the ones that are factored are limited. You can make plenty that aren't factorable. So this is test maker's hat. You know these probably were going to work out. All right, first step, put your C. Put your 8. The reason why we need two numbers that multiply to give us 12, think of it, these last two numbers multiply with FOIL. The last ones multiply to get you a number. Those same values that multiply, whatever these values are, combine with x's and add to give you 8. So FOIL kind of shows why that works. If you don't understand that exactly, then let's just use the method till we do. And let's see. What multiplies to give me 12? 6, 2, negative 6, negative 2, 12, 1, negative 12, negative 1, 3, 4, negative 3, negative 4. That's it, right? Which one of those adds to give us 8? Positive 6 and positive 2 give us that. So x plus 6, x plus 2. Done. Factor form. Thumbs up's always down for using the X method for this step. Good. Let's look at this one now. Standard form to vertex form. What do we have to do? Complete the square. Maybe this will remind you we have to complete the square. We're going to be doing our algebra tile work. Let's go ahead and do that for this one. Let's set it up. Okay, 8x, look how we broke it up. 4x is here, 4x is here, that's nice. Now, from there, we know that x times x gives us the x squared. I have added to that 1, 2, 3, 4. Over here, 1, 2, 3, 4. We know for completing the square, our two binomials are going to be identical, so we're on the right track. How many do I have as far as ones? 9. I'm just going to do this. I need to figure out how many more I have to have here. So, what do we see? How many do I need altogether? 16, because look, that's a 4. That's a 4. They multiply. They multiply to give us 16. So what do I need to add? 7. I need to add 7 to this, and then what do I need to subtract? 7. Okay, good. Now, we have this box right here. Is it a perfect square, basically? It could be a little better, but we have x plus 4. We have two of them. Multiply it and then start, get to factor, start, get to vertex. Okay. I hope it's like a roadmap. You see where I am, where I need to go. You know your tool. Nice. All right, next, I know some of you have been saying, well, what if you're going from factor to vertex form? What do we do then? You got to go to standard as like an in-between. So if I'm here at factored form, to get to vertex, I got to go and use FOIL to get to standard, complete the square to get to vertex. It sounds like it's going to take a long time, but with FOIL, I feel like we have FOIL down. We did pretty dang well on that assessment. So let's see about this. Let's see about it. Okay. I say we do the FOIL part together because I don't think we got to review that too much. First is x squared, x times x. You guys are doing it. Okay, keep doing it. It's like, let us work. Okay, outer, negative x, inner, plus 3x, last, minus 3. Combine them, we got standard form done. Good. Standard. It's just FOIL. It's just the FOIL. First, outer, inner, last. We have two binomials.
Wait, where'd you get 3?
Because it's the first one is -3 and the second one is -3x. So would it just be x squared plus x plus that?
Let's see. First gives us x squared. Outer gives us negative 1x.
Okay.
Inner gives us positive 3x. Last gives us the negative 3. So that's how I arrived at it. Now, all I did to make this get to 2x, I have negative 1x and positive 3x. You just combine them.
Wait.
What if I had it written this way, though? That might be easier to see that's 2x. Ah, brain hurts. Yes?
So the y parentheses x plus 3 and stuff like that. So that's the outcome of a factored problem.
Correct. We're starting at the factored form.
And then we change it to standard form.
Good. To get to
Vertex. So then now we have to make the square after that.
perfect square with this one. I know. It's 2 steps. But really think of, I know it's like 2 problems, so I won't make you do that one too often. 2, 2, 2, 2. All right. Let's go ahead and get it to vertex form. I'll let you work on that with completing the square, get into vertex form. I'm going to check what's going on back here.
I kind of got lost.
So when you go that long route, in your factor, you got to pull this first.
Do the arrows.
Arrow it up.
So come back to the
Let's see. This is about as tricky as I've given you so far, but just remember, here's the deal. X plus 1. X times x gives me x squared. X times 1 gives me x, so this is x plus 1 and x plus 1.
So are you supposed to add 4 to get the 1?
Tell your neighbor, what do you think we're going to do? Because to make a perfect square, this can only be 1, but I already have in here a negative 3. Tell your neighbor, what do you think we're going to do in order to get to 1? negative 3 plus 2 is negative 1. How many more? Got it. If you got this, you got
Is
it.
this the negative part you did yesterday?
Yeah.
So is that for all negatives? You can find a difference.
I think of it this way. It's like a vessel. Like this is a container that's 1 unit. Right now I have negative 3 units kind of abstractly in the container. To get to 1, I have to add. Okay, let's see what group feels like they know it. Feels like they have it. No. Ethan, Mr. President, you gotta be a leader. What did you do? If you know the vessel is 1 times 1, so this is a 1 block, but we have negative 3 within that vessel. What are we going to do in order to make it 1? Boom. So here we're going to plus 4. Let's see if that works. Plus 4 and negative 3 in one container give you 1. I added 4. What do I need to do out here? Well, the negative 3 is all encapsulated in there. That's almost the same like how we had a 9. We had to add 7. So that's already dealt with. Plus 4 and negative 3 give you 1. So it's just this. X plus 1, right? There's 2, it's squared because we have perfect squared, minus 4. Yeah.
Yes.
Yep. Thumbs up, sideways down. What do we feel? Even if we don't like it, can we do it? We can force ourselves with notes.
Yeah.
Do you say yes? No? Okay. All right, guys. Great job. I know that this was a heavy lesson. Do we just want to yell broken brains on 3?
Yes!
As loud as you can.
Yes!
All right, broken brains on 3. 1, 2, 3.
Broken brains!
That's what happens in my class.